Welcome to tonight's video on topic 3, combinations of functions and composite functions. First, we're going to talk about the domain of functions. The domain of a function is all real numbers, so the default is all real numbers, except in the following situations. When the denominator of the fractions, like for example, 1 over x plus 3, so therefore you know that x cannot equal 3. Right, or negative 3, sorry, whatever makes the bottom 0. And then also negative numbers cannot be under radicals. So if you have the square root of x minus 2, you know that x minus 2 has to be greater than or equal to 0. So x has to be greater than or equal to 2. So we are going to figure out what x can't be, because that often is what helps us to determine what x can be. All right, and remember, the default, if there are no denominators or even roots, then the domain is all real numbers. So for example, in number 1, we know there's a fraction here. So we know that x minus 1 cannot equal 0, so x cannot equal 1. So if x cannot equal 1, it can equal everything else. So I'll just draw a number line to show you. So here's 1. It can't be 1, but it can be everything else. Infinities here, negative infinities here. Right? So when you write it as an interval, you're saying it's from negative infinity to 1, and then union 1 to infinity. Number 2 is not a fraction or a square root, so therefore the domain is all real numbers. Number 3 is a square root, so you know 2x minus 3 has to be greater than or equal to 0. So 2x is greater than or equal to 3. X is greater than or equal to 3 halves. So basically, you know it has to be bigger than 3 halves. It can start at 3 halves, and then it has to go bigger, right? And it's a bracket because it includes the 3 halves. It's equal to. For number 5, we know that x squared minus 49 cannot equal 0. So now when you factor this, you get x minus 7, x plus 7 cannot equal 0. So you set them equal. And notice that x cannot equal 7 or negative 7. So if you look at this on a number line, here's negative 7. Here's 7. Here's negative infinity, positive infinity, right? So it can't equal those two, but it can equal everything else. So when you write the interval, you're going to say from negative infinity to negative 7, union negative 7 to 7, union 7 to infinity. All right, so algebra of functions, like combining them. So this means to add them. So we go f of x plus g of x. So f of x is 2x, and g of x is x minus 1. So basically, it's going to be 3x minus 1. That is f plus g of x. And the domain for this is all real numbers. Whenever you're finding the domain of a composition, if you find the domain of f of x, and take the intersection of the domain of g of x, that'll give you the domain for any of the compositions. Well, in this case, they're both real numbers, so the intersection is just all real numbers. So for this one, the domain is going to be all real numbers. Same thing here, you subtract. Remember, distribute the minus first. And so you get x plus 1, and remember the domain for f minus g is going to equal all real numbers. F times g, so this is f of x times g of x. So we're going to go 2x times x minus 1. So now you're going to distribute, and you get 2x squared minus 2x. The domain for f times g is all real numbers as well. Now f over g, that's f of x divided by g of x. And so this will be 2x over x minus 1. The only difference here is that now we know that x cannot equal 1, right? So when we do the domain, we are going to say that it's from negative infinity to 1, union 1 to infinity. So basically it's everything but 1, because 1 would make the denominator equal 0. So here we have an example, all right? So the domain of f, right, that's x is greater than, so x plus 3 is greater than or equal to 0. So x is greater than or equal to negative 3. The domain of g, you would have x minus 2 greater than or equal to 0. So x is greater than or equal to 2. Now, where do they intersect? Well, if you think about it on a number line, right, here's negative 3, and here is 2. So notice, like, where they intersect. They would intersect right here. So any combination is going to have a domain that is greater than or equal to 2. So when we add them, now remember, you cannot add or subtract under the radical. So it just stays like this, and therefore the domain of f plus g is greater than or equal to 2. F minus g, so you go the square root of x plus 3 minus the square root of x minus 2, and the domain of f minus g is greater than or equal to 2. Here, when you go f of x times g of x, now when you multiply, you can multiply under the radical. So x plus 3 times x minus 2, this is where you would FOIL, and you would get x squared plus x minus 6. And the domain of f times g is still greater than or equal to 2. Now f of x over g of x, so you would have the square root of x plus 3 over the square root of x minus 2. And remember, you can rationalize the denominator. So that would be the square root of x squared plus x minus 6 when you FOIL over x minus 2, because remember, when you multiply by the square root, it just removes the square root time. So now, the only difference in the domain here is that when you divide, it can't equal 2, because that would make the bottom 0. All right, so then the next thing we're going to talk about is composition of compositions. And here it gives you the domain. Basically, analyze the domain after the substitution, analyze the domain after the simplification, and consider them to 1 and 2 together. And we're going to talk about that as we go along. But the compositions, f of g of x and g of f of x, so whenever you see it, you're going to rewrite it in parenthesis form. So f parentheses g of x. So first, you're going to substitute in for the g function. So I'm going to replace g of x with what it's equal, and it's equal to x squared minus 2x plus 6. And now I'm going to put that in the f function. So I'm going to take 3 times x squared minus 2x plus 6, because that's what's here, right? It tells me whatever whatever x is, I put it right there, and then minus 4. So when I combine like terms, I get 3x squared minus 6x plus 14. The domain of f of g of x, in this case, would be all real numbers, because it's all real numbers for f, g, and the composition. G of f of x, I'll rewrite it in parenthesis form, but now I'm going to take f and put it in first. And then I'm going to put that in, so I get 3x minus 4 squared minus 2 times 3x minus 4 plus 6. So when I FOIL 3x minus 4, I get 9x squared minus 24x plus 16. And then when I distribute the negative 2 here, I get minus 6x plus 8 plus 6. So remember here, you had to do the 3x minus 4 times the 3x minus 4. That's how I got that. So 9x squared minus 30x, when you combine like terms, and then 16 plus 8 plus 6 is plus 30 as well. So the domain here of g of f is also all real numbers, because there are no fractions or square roots. F of g of 0, so what that means is first you're going to find g of 0. So that's 0 squared minus 2 times 0 plus 6. So g of 0 is equal to 6. And now you're going to replace this with 6. So it becomes f of 6. And that is equal to 18 minus 14. So f of g of 0 is equal to 14. So then g of f of 1, so that's the same as first finding f of 1, which is 3 times 1 minus 4, which is negative 1. And then we're going to take g of negative 1, which is negative 1 squared minus 2 times negative 1 plus 6. So it's 1 plus 2 plus 6, so it's equal to 9. So g of f of 1 is equal to 9. All right, so the next one, f of g of x. So we'll go f parentheses g of x. So we put the g in first, so 2x squared minus x minus 1. And then we put that in the f function, so 5 times 2x squared minus x minus 1 plus 6. So you get 10x squared minus 5x plus 1. So the domain for f of g is all real numbers, right? Because there's no fractions. So g of f of x, now we're going to substitute in the f. And now we're going to put that in the g function. So 2 times 5x plus 6 squared minus 5x plus 6 minus 1. We'll FOIL here. So it's 25x squared plus 60x plus 36. Distribute the negative, so minus 5x minus 6 minus 1. Have to multiply what's in the parentheses here by 2. So it's 50x squared plus 120x plus 72 minus 5x minus 6 minus 1. So 50x squared plus 115x plus 65. Domain of g of f is all real numbers because there's no fractions or square roots to deal with. F of g of 1, well, g of 1 is equal to 2 times 1 squared minus 1 minus 1. So it's 0. And then f of 0 is 6. G of f of negative 1. So f of negative 1 is 1. And then g of 1 is 0. All right. So the next one. So here's where you have to consider the domain. So f, the domain, you know x cannot equal 2. And g, you know x cannot equal 0, right? So f of g of x, when you do that, so you put the g in first, so it's 1 over x. And now I'm going to take that 1 over x and put it in the f. So now when you have a fraction within a fraction, you can multiply to get rid of the, or sorry, not by 2, but by the denominator, which is x. So if we multiply by x, we get 4x over. Here, when you multiply, the x cancels, so 1 minus 2x. So that is f of g of x. So notice the domain here is that x cannot equal, well, 1 minus 2x cannot equal 0. So 1/2, right? So because you're putting in 1 over x, right? So you know x can't equal 0. And then after this, it can't equal 1/2. So the domain for f of g of x is that it can't equal 0 or 1/2. Because you could put 2 into either one of these two, you just can't put 0 or 1/2 in. So now, if we look here, g of f of x, so f of x is 4 over x minus 2. So we have 1 over 4 over x minus 2. So basically that means we're just going to flip the fraction, so it's x minus 2 over 4. So here the domain is all real numbers, right? Here, though, you cannot put in 2. You can't put in 2 to the 4 over x minus 2, but you can put in anything to the end. So the domain of g of f is from negative infinity to 2, union 2 to infinity. F of g of 1, well, that means you put g of 1 into g first. So 1 over 1 is just 1. And then f of 1 is 4 over negative 1, which is negative 4. G of f of 1, or negative 1, sorry. So f of negative 1, 4 over negative 1 minus 2. So 4 over negative 3. So g of negative 4/3. So 1 over negative 4/3 is the same as negative 3/4. Final answer. All right, the last thing here is decomposing functions. So when you have two functions, all right, h of x equals f of x, f of g of x. So the g function is the inner function. What is inside of the composition? And the f of x is the outer function. So for example here, the inner function is 3x minus 5. So that is your g of x, 3x minus 5. The outer function, the f of x, well, you multiply by 2 to the square root, and you add 4. So that is the outer function. All right, I hope you enjoyed the video, and if you have any questions, please feel free to ask them in class.